IT and OT are converging. As building systems get smarter and this integration deepens, it becomes increasingly important to understand the underlying mechanisms behind these systems. One major player for consideration in the operational technology space is the Modbus protocol. Modbus was introduced in 1979 by Modicon, which is today known as Schneider Electric. Modbus is one of the most widely used network protocols in industrial environments because of its openness and simplicity. Because thousands of vendors have adopted the protocol, Modbus is not only used in industrial buildings, but can be found in many commercial building, infrastructure, transportation, and energy applications today. Let's take a look at the methods of transmission Modbus uses and how they operate on a basic level. Modbus is a serial communications protocol, acting as a messaging structure that is used to establish master, slave, and client-server communication between intelligent devices. There are three transmission methods that are used. They are Modbus ASCII, Modbus RTU, and Modbus TCP. Modbus ASCII and Modbus RTU use EIA 232 or EIA 485, which are twisted serial data cables that are low cost to transmit data. Modbus defines function codes and encoding schemes for transferring data as either binary points, 1 bit known as coils, or 16-bit data known as registers. This basic data packet is then encapsulated according to the protocol specifications for Modbus ASCII, RTU, or TCP. The most commonly used form of the Modbus protocol is RTU, Remote Terminal Unit. Modbus TCP uses Modbus RTU protocol with a TCP interface, meaning it can run over Ethernet. Additionally, it can be run over IP to enable internet connectivity. So again, while Modbus RTU is used most frequently, the data can be wrapped into a TCP protocol, enabling common internet connectivity to these networks, as is expected by modern systems today. Such is the case with KMC Commander, our IoT platform, which supports Modbus TCP. With KMC Commander, you can connect all these devices to the cloud and aggregate their data to track and trend equipment performance remotely and set up alarms as needed. Now let's talk about some of the technical aspects of Modbus. Modbus is a master-slave messaging system. This means that a master device talks to all the other devices on the network. It can query them for information or tell them what to do, but the slave devices themselves won't talk until queried. Each slave has a unique 8-bit device address or unit number. Packets sent by the master include the address of the slave device, the function code, which defines what the master device is asking, and the data for the query. The slave must then respond within a certain period of time, or else a no response error will occur. In contrast to other protocols like BACnet, you can't auto-discover a network. You need to know the correct device addresses and points you are trying to view and control. In Modbus, data is stored in 4 different tables. A vendor may decide to use only one table or a combination of tables depending on what data types the devices provide. 2 tables store binary on-off values known as coils, and 2 tables store numeric values known as registers. The coils and registers each have a read-only table and a read-write table, again depending on what the device allows. A Modbus message typically contains 5 parts. First, the device address. Second, the function code, or what we want the device to do. Third, the coil or register address, which is the address of the data that we want to access. Fourth, the data value at the address or the value we want to write to that address. And fifth, the CRC, or cyclic redundancy check. This allows the data to be error checked for any problems in the raw data being sent or received. Now that we have a basic understanding of the data moved in Modbus, let's talk a little bit more about how Modbus over TCP can be seen differently. Modbus TCP allows for peer-to-peer communication, essentially allowing multiple master and slave devices to live on a single network. By using TCP, we can think more in the lines of servers and clients. The slave becomes the server and the master becomes the client. There can be more than one client obtaining data from a server. Rather than defining master and slave on a device-by-device basis, as you normally would, the system designer can create logical associations between master and slave functionality on the network. This allows the architecture to be more dynamic and simpler, as now the masters and slaves can all communicate in a more open way between more devices rather than one at a time. This is just the surface of how Modbus works. To learn more about the protocol, visit modbus.org. And to learn more about any of the solutions from the building geniuses at KMC, visit us on the web at kmccontrols.com.